The next thing I want to talk to you about is sum and difference of cubes. We've talked about the difference of squares and how if we have difference of squares, they can be factored. And we talked about how if we have the sum of squares, we can't do anything with that. But if we have the sum and difference of cubes, of a cube number, if both of them are cubed, then we can factor both of those. It doesn't matter whether it's a sum or a difference, those can both be done. So I'm going to show you a real simple example first, and then we'll get into some that are maybe a little bit more complicated. So if I have something like x cubed minus 8, we'll do x cubed minus 8, and we'll do x cubed plus 8 so that you can see that they both work. Okay? Now, how do I recognize difference of cubes? Well, this x cubed, that's the cube power or the third power, means that that's x times x times x. So if we have any exponent here that is divisible by 3, it will be a perfect cube. Again, if the exponent is divisible by 3, it will be a cube number. So like x to the 6th, x to the 9th, x to the 12th, any of those would be perfect cubes. And then for this number, we could just take the cube root of that number on our calculator. If you recognize that this one is a perfect cube, then you need to see if the number is a perfect cube. If it is, then if the directions say factor completely, this is the method you would use. And 8, if you think about that, is 2 times 2 times 2. So 8 is also a perfect cube. Okay, now to factor difference or sum and difference of cubes, the method is the same for both of them. There is just a little phrase that you need to memorize. And that phrase is same, different, plus. If you can remember that phrase, the rest of factoring difference and sum and difference of cubes is pretty easy. Okay? So here's what we're going to do. When I factor difference of cubes, I'm going to have 2 sets of parentheses just like when I'm factoring trinomials. But my second parenthesis is going to have 3 terms instead of 2. Okay, so I need to make sure I have room for 3 terms here. To do the sum and difference of cubes, to factor them, what I do is I take the cube root of the variable. So the cube root of x cubed is x. That's what goes right there. I take the cube root of the number part, or the second part. That is 2. So I put a 2 right there. Okay? To get the first term in my trinomial part, what I'm going to do is I'm going to take this number, or this variable, whatever it is, and square it. So what is x squared? Hopefully you're saying x squared. To get the last number in this one, I'm going to take this number and square it. So what is 2 squared? That's 4. To get my middle term, what I do is I multiply these 2 things together. So x times 2 is 2x. That's my middle term. And then for my sign, see I need a sign here, here, and here. They either have to be plus or minus. To get those signs, that's where this phrase comes in. This one is the same, this one is different, this one is a plus. This one is always a plus, okay? Same means it's the same as the sign we started with, a minus. Different means it's different than the sign we started with, so that'll be a plus. Plus means this is always a plus, okay? So I have factored that difference of cube problem. All you have to do to make sure this works is to FOIL. I'm going to FOIL this one just to show you why it works. But you will not have to FOIL when you're doing this in your homework or in your classwork. All you have to do when it says factor completely is this. This would be the answer. Okay? Now, this is a trinomial. When the directions say factor completely, you should always check to see if the trinomial factors. Okay? Are there factors of 4 that add to give you 2? No, there are not. So you can't factor that one any further. Okay? So let's FOIL this so that we can see, or we'll multiply. It's not really FOIL. We'll multiply these together to see if that's what we end up with. So in order to multiply a binomial times a trinomial, what I do is I take the first term and multiply all the terms in the second set of parentheses. So x times x squared is x cubed. X times 2x is 2x squared. X times 4 is 4x. Then I'm going to take the second term and multiply by all of them in the trinomial. Negative 2 times 2x squared is negative 2x squared. Negative 2 times 2x is negative 4x. Negative 2 times 4 is negative 8. Then I'm going to add my like terms. Well, hopefully you notice 2x squared and negative 2x squared and 4x and negative 4x, they cancel. So that leaves me with x cubed minus 8, which is what I started with. So that must be true. We must be able to factor sum and difference of cubes. Okay? So let's look at the one that has the sum to make sure that works. Well, what's the cube root of x cubed? That's x. The cube root of 8 is 2. This term is this one squared, so that's x squared. The last term is this term squared, so that's a 4. The middle term is these two multiplied together, so that's a 2x. Then my signs are same, different, plus. This is the same as what we started with. This is different than what we started with. This is always a plus. Okay? Then I could FOIL it if I want to see that it works. X times x squared is x cubed. X times negative 2x squared. X times 4 is 4x. 2 times x squared is 2x squared. 2 times negative 2 is negative 4x. 2 times 4 is 8. These cancel, leaving me with what I started with. Again, once you get here, that's all you have to do. The only reason I'm doing this is to prove or show you that it does, in fact, work. If you notice, it is the difference of squares, because that's even. And it's the difference of cubes. Think about it. 64. Isn't that 4 times 4 times 4? Isn't 6 divisible by 3? And 1 is the same thing as 1 times 1 times 1. This one is both difference of squares and difference of cubes. When that happens, you always want to make sure you do difference of squares first. You'll understand why in just a minute. So if I do this one as a difference of square problem, the square root of 64 is 8. The square root of x to the 6th is x cubed. Remember, you're dividing the 6 by 2. That goes in the front of each of the sets of parentheses. The square root of 1 is 1. Then my signs would be a plus and a minus. That's how we factor difference of squares every time. Now look at what's left. We have a cube and a cube. We have the sum of cubes here. Look at what we have here. We've got the difference of cubes here. So now we need to factor both of these again. They're both cubes, perfect cubes. So this is the sum of cubes, this is the difference of cubes. So I'm going to factor this one. I do my 2 sets of parentheses. The cube root of 8x cubed is 2x. The cube root of 1 is 1. This is 2x squared, so that would be 4x squared. 1 squared is 1. The middle term is these two multiplied together, 2x. My signs are same, different, plus. This is the one we factored, so the same sign goes here, different sign goes here, always a plus there. For this one, I'm going to do the same thing. Cube root of 8x cubed is 2x. Cube root of 1 is 1. 2x to the second power is 4x squared. 1 to the second power is 1. These two multiplied together is 2x. Same, different, plus. Then look at the rest. The 2x plus 1 and the 2x minus 1, they can't be factored anymore. This one, 4 times 1 is 4. Are there factors of 4 that add to give you 2? No, there are not. 4 times 1 is 4. Factors of 4 that add to give you 2, we can't do that. In fact, I've never seen a trinomial for a perfect cube that actually factors, okay? So at this point, you would be finished. Always double check, but we have now factored that one completely. Here's another type of trinomial problem that I want to make sure that I show you, because the further along you go with factoring, the more difficult some of your factoring completely problems can be. So I want to make sure I show you these. This is something that's going to show up the further you go in your math courses. So it's good to at least be exposed to it at this point. If I were to factor this one, hopefully you're noticing this says x to the fourth. And normally when we have a problem like this, it would be something like this, 6x squared minus 7x minus 3. And we would factor that trinomial using, or 6 times 3 is 18, factors of 18 that subtract to give you 7, okay? This one really isn't any different. We're going to factor this one the same way, but sometimes what we end up with can be factored again, okay? And what you need to realize with this one, okay, when we factor, well, if we're looking for factors of 18 that subtract to give us 7, we know that's 9 and 2, okay? So we're looking for a 9 and a 2 in our inside and outside terms. So to get 9 and 2, 6, I could use 1 and 6 or 2 and 3. Well, 1 and 6 isn't going to work to give us a 9 and a 2. So I need to use 2x and 3x. And then to get 2x times what would give me a 2? Well, that's 1. 3x times what would give me a 9? That's 3. And then 3 times 1 is the 3. So just to kind of review that factoring of that trinomial. But what I really want to concentrate on here is to understand that if this is an x squared, your middle term is going to have an x. And whatever that middle term is going to be the power of your x term in the first part of each binomial, okay? And then with your signs, we know these are going to be different, and the 9 gets the minus, so minus plus. There it is, okay? Now, how does this relate to something like this? Well, x is the square root of x squared, okay? So that's where this number comes from. It's the square root of that highest power variable, right? Same thing is going to happen here. I'm going to do this one exactly the same way. I'm going to say 6 times 3 is 18. I'm looking for factors of 18 that subtract and give me 7. That's still 9 and 2, okay? But this time, when I put my variable here, I know my variable part has to be x squared because that's what the square root of x to the fourth is, okay? So I know I'm going to need 2 and 3, but what variable do I need? Well, it has to match that middle term, x squared and x squared. And then I know 2 times 1 is 2, 3 times 3 is 9, and I know my signs are different. The minus goes with the 9. So look at those. They're very, very similar, but because this was x to the fourth and this was x squared, that changes what the first term in each binomial looks like. And then when I get to this point, I need to double check and make sure I can't factor any further. Sometimes you will be able to. In this case, I can't. There's nothing I can do with either one of these to factor it further. So here's another one I want to try. Again, your directions are factored completely. So if I'm looking at this one, the first thing I'm going to do is hopefully recognize that all of these have a 2 in common. So I want to bring that 2 out first to make it a little bit easier on myself. And then I want to see if I can factor this trinomial. X to the fourth, the square root of that is x squared. Okay, so I know if I factor it, my variable part is going to be x squared and x squared. Factors of 25 that add to give you 26. Well, that would be 1 and 25. So I'm going to keep the 2. I'm going to do my 2 sets of parentheses. The square root of x to the fourth is x squared. Factors of 25 that add to give me 26 are 25 and 1. The plus tells me these are the same sign and they're the same as the middle term. So see, nothing there is new other than the x squared here. Okay? So now look at what you've got. Some people would stop there, but hopefully from this lesson you've recognized this is the difference of squares and this is the difference of squares. So we can go further. So I have the 2, I keep it. X squared minus 25 is difference of squares. The square root of x squared is x. Square root of 25 is 5. And I know they need different signs. One's plus, one's minus. For this one, the square root of x squared is x. The square root of 1 is 1. And they need different signs. Now that one has been factored completely. So hopefully this lesson on factoring completely has given you some tools that you need to recognize when you can't stop, when you have to keep going, and make sure you're looking for difference of squares and sum and difference of cubes. If you don't recognize those, sometimes you might miss some answers because you're not factoring completely. So you have to be real careful to make sure you're purposefully looking for sum and difference of cubes and difference of squares.